Right. So, welcome to the second day of the machine learning online workshop. So today, what we are going to do is we are going to continue what we have started yesterday, and we got to know about uh, machine learning algorithms, and we discussed about supervised machine learning. So if I brief you what we did last time, we got to know about AI, machine learning, and deep learning, and we got the idea about what are the differences between each one. And thereafter, we got to know that there are three main categories when it comes to machine learning: supervised, unsupervised, and reinforcement. So we select the supervised machine learning section, and under supervised machine learning, we discuss how the supervised machine learning works, simply the model of supervised machine learning. So in supervised machine learning, we got to know about two things called features and labels. And when we have a problem, we need to have we have to define the features and labels in order to use machine learning for problem solving, right? Okay, so um, did you all got the basic Python programming tutorials? No? Okay. Um, the thing is now, actually, I'm not sending you the things. There is a organizer for this workshop, so I asked the organizer to send them yesterday, right? And I thought that he sent it, but let me. Um, sorry about this. I asked him to send them to you all, right? Anyway, yeah, I will yeah, give me a second. Okay, so I'll confirm you and let you know what's the issue. But anyway, yeah, so we got to know about this, and thereafter what we did was we discussed about machine learning algorithms and supervised and regression, classification and regression problems, and we got to know about machine learning algorithms. And finally, what we did was we applied this. We got this problem, Aris flower example, and what we did was we apply this data set. We got to know about data sets, and we define the features and labels, and we had a data set with 150 samples. So what we simply did yesterday was uh, we trained it for right. So we trained it, and finally we trained the machine learning algorithm, and we split the data set into two. And we trained the machine learning algorithm, and we got the k-nearest neighbor algorithm, and thereafter we trained it. And after with the testing data, we test the algorithm, and we got the actual and result. I mean, the actual and predicted, and we compared it by measuring the accuracy, and that's what we did last time, right? So now, actually, the practical part was done, right? Uh, the practical part was done yesterday, and now we will quickly. So the practical is there for the handwritten character recognition. There's a practical today, so we will do that. But before going on to that, we will quickly got to know how k-nearest neighbor works, or how k-nearest neighbor actually gives this prediction, and how it's trained and everything, right? How it's going to give this kind of new prediction. So we are going to discuss about it, right? Okay. So yeah, now so I'm going to discuss about the k-nearest neighbor algorithm. So the k-nearest neighbor algorithm, as I mentioned, is a very easy to understand and a very simple machine learning algorithm. That's why we are going to learn this as the first machine learning algorithm, right? Since it's quite easy to understand, it's a very simple, based on a very simple theory. That's why we are going to learn about this. But don't think that, okay, since this is simple, don't think that it's like, okay, it's an inaccurate algorithm, right? Not like that. So I will mute you all now. If you have any issues, you can unmute and ask. Right, for now I will mute you all. So as I mentioned, this is the best, not the best, but the simplest. But don't think, okay, since it is simplest based on a very simple theory, don't think that this is going to give you like bad results or inaccurate results. No, it still gives you best good results with good accuracies, but it works with a very fundamental and a very simple theory. That's the idea, right? And this is used in mostly in finance sector applications, right? Finance sector applications, as well as political science, right? Handwritten digit recognition, right? And finance institute, as I mentioned, loan disbursement, bank institute, they use this kind of things, right? So political science, KNN is quite heavily used for like to predict the potential voters to which party they are going to cast their vote, right? Likewise, the potential voters, the predict how to get a prediction of the party, which party they are going to cast their vote, right? Likewise, and finance, as I mentioned, like banks, institutes, they use softwares based on k-nearest neighbor algorithm, which can decide like a loan is safe or risky. Once someone applied for a loan in a bank, his or her details will be applied to a software like the age, the gender, the monthly income, right? The children's, right, number of children's in the family, right? Likewise, all the details will be applied to a software and it's going to predict this is risky or not, or it's going to give you like a value, a rating between 0 to 100, like risk kind of a thing, factor, right? Now, the banks, they have the previous data, I mean, previous data of their customers. So they can like, they have the records whether a customer is settle the loan uh, or not, right? So likewise, those kind of data are there, so they can simply uh, get the label risky or not, right? And the features like age, gender, monthly income, number of children, likewise, right? I think you can get idea. So that's how it simply works. But I mean simply, but they are more advanced than that. But I just explained the simplest applications, right? Okay, so that's what k-nearest neighbor is about. So we will get to know how k-nearest neighbor algorithm works, right? So for example, this example, I'll take a very simple example as we did for the feature and label identification. But in this case, I'm going to reduce the number of features to 2, right? I'm going to assume that there are only 2 features available. And the labels, like 2 labels, 0 and 1, right? Okay, so let's take a sample example. Let's assume that this is the uh, this is the um, what you call the uh, data set, the historical data, right? So we have a data set. Now don't think that 6 elements, I mean 6 data, number of data is not enough, data points are not enough, but for example, we are going to take it. So what we can do is, now if we can take this temperature into x-axis and humidity into y-axis, I can plot a graph like this, right? I can simply plot a graph like this. So this is simply like all the data points represented in a 2-dimensional graph, right? By taking the temperature into x-axis and the humidity is into y-axis. So now you have to keep an idea, I mean, keep a track that this is the feature number 1, right? And this is the feature number 2, right? So we take the 2 features into the x and y axis and we can plot it, and simply the color represent the label, right? So it's like, okay, green for no rain and red for rain. So the label is represented by the color. I hope you can understand. So we can get the data and we can plot it in some kind of 2D graph like this, right? So very simple. Okay, so that's actually what happens in training. So in k-nearest neighbor, there's nothing happening in training, right? When you are going to model.fit, train data, train target, actually nothing happens. Just like it's storing the data, right? Actually, no, actually the algorithm is not trained. I mean, Mathematically, nothing happens. It's just get the train data and train target and store it into arrays. That's all, right? Thereafter, what happens? Actually, the k-nearest neighbor does everything at the training, right? I mean the testing, sorry. K-nearest neighbor does everything at the testing. So once a new data is taken, like, okay, let's say that we have a data which we want to get a prediction, right? So like, let's say the data point shown in the blue color, right? So 33 temperature, 35 humidity, right? So it's like this now. In the code, this is like this. If you take the code, it's like model.fit. So we are going to apply test data, right? Test data. And in this case, the test data is equals to what? The test data is equals to 33, 35, right? So we apply it to the algorithm. So what the algorithm simply does, now, as you can see, as you can, like, I mean, the name, as the name suggests, k nearest neighbor. So it's going to like, once the data is given now, the blue color, that means the blue color point, we don't know the label. So the label should be predicted. The algorithm should predict what's this label, right? It should give a prediction. That's the duty of the algorithm. Once the model dot, sorry. This should be model dot predict, sorry. Okay. So once something is given to the model dot predict, right? So it should give you the label, whether it's 0 or 1, right? It should give you like whether it's 0 or 1. That's what should happen, right? So we have applied the data to be tested. The label is unknown. So we are expecting the label from the k-nearest neighbor algorithm, right? So what happens when the data is given, data to be predicted, its label is unknown. So I'm representing it in the blue color. So that means the label is unknown. We don't know whether it's a rain day or no rain day. What happens? The nearest neighbor algorithm finds the nearest neighbor for that data point, the data point to be predicted, right? It's going to find the minimum, the nearest neighbor to that data point to be predicted, right? So you can see, if you take the nearest one, if you consider the nearest one, I think this would be the nearest one, right? So then what happens, since the nearest neighbor of this data to be predicted is a green color one, that means no rain, this will be also predicted as no rain. Understood? Since the nearest one is a green color one, that means no rain. That data point is predicted as a no rain day. So simply, right? So that's why I told you that this is a very simple algorithm, right? So you can see a very simple algorithm. But now, the thing is, we can see, since we have the visual feedback of this graph, we can see that the nearest neighbor is this green color one. But the machine learning algorithm is not going to see this kind of a graph. It's going to just see the set of numbers for temperature. That means the feature one, set of numbers in the humidity. So how it's going to identify the nearest one? Any idea? Now we can get the visual feedback after plotting it, but the algorithms, they can't get this kind of visual feedback. They have just numbers, array. So from the array, do you have any idea how this nearest one is found? Yes, we are getting several answers. No, most number of nearest data, no. Yeah, my question is, it's going to take the nearest data point, and the label of that point will be given as the predicted label, right? Now, once a new point is given like to be predicted, like the blue color one, it's going to identify the nearest data point to that point, right? and give the label of that point, the nearest point, as the prediction, right? My question is how it's going to identify the nearest data point. I mean, it can't see this kind of a graph. Yes? Any idea? Another answer? Yeah, exactly. Based on the distance, very good, right? So what the k nearest neighbor algorithm is going to do, it measures, I mean, the thing is we can see this nearest one, but the algorithm can't since it sees some numbers. So what's going to do, it measures the distance to all the data points in the training data, right? All the data points in the training data, it's going to measure the distance to all the data points, I mean from this blue color one to all the training data points, it's going to measure the distance. So if you have n number of training data points, right, if you have n number of training data points, this is going to measure n number of distances. That means it's going to measure the distance for each and every training data, and out of them it's going to select the minimum distance, right? So the data point from the training data which has the minimum distance to the data point to be predicted, that will be the nearest neighbor. Then that the data point which has the minimum nearest neighbor, label of that one will be predicted as the label of the data to be predicted. Understood? Right? So that's how it's done now, right? Yeah, now you know how, like for this kind of 2D thing, you know how the distance can be measured, right? So if you want this distance, you know how to do this, right? So if you say that this is like, okay, 60, and this is 28, and this is 35, and this is, I think, somewhere 33, let's say, right? So the distance will be the Pythagoras, you know, right? So it will be the difference between x, right? Difference between x, that means 33 minus 28 plus 60 minus 35, and the square root of that, right? So likewise, this is how one distance is measured, right? A single distance is measured like this, and right. So Pythagoras distance, simply the Pythagoras distance, and what happens is, similarly, all the distances will be measured. I mean, all the distances in the sense like distance to all the training data points, right? Understood? So this is simply, you know, the Pythagoras, right? X1 minus x2 squared, y1 minus y2 squared, the square root of it, right? Addition and get the square root. Understood? Got it? Right. So that's how it's done. So it's going to measure all the distances using the Pythagoras distance and get the minimum distance like this, and which the nearest neighbor which has the, I mean, the nearest neighbor will be the data point which training data point which has the minimum distance. It will be the nearest one, and the label of that one will be predicted as the label of the data to be predicted. So this will be predicted as NOR and A. Understood? Right? But the thing is, now in actual scenarios, we don't have like always two features, right? We have multiple features. In our example that we consider as well, the iris flower example, it contains like 4 features, right? So you can simply, you know that simply when you have 2 features, it's quite straightforward. When you have 2 features, it's quite straightforward, since you have to get the distance between x and distance, like it's like the Pythagoras distance, right? But what if you have more features? If you have 3 features, how we are going to calculate the distance? 3 features, 3 features, 3 features. Like feature 1, let's say feature 1 is x, feature 2 is y, and feature 3 is z, let's say. So the distance like between 2 data points, how? X1 minus x2 is squared, y1 minus y2 is squared, z1 minus z2 is squared. Understood? So this is how we are going to get the distance between three features, right? Assuming that x is the feature 1 and y is the feature 2, like this one, right? So this is simply called the Euclidean distance, right? Euclidean distance, uh, right? Euclidean distance. Now we have three features x, y, z. So we have to get it. So this is called the Euclidean distance method. Now, when you have, when it's 2D, Euclidean distance become Pythagoras, right? But if you have more than two features, that's called Euclidean distance. How we are going to measure the Euclidean distance? It's like this simply. Now, let's assume that you have four features like this, and assume that this is the point 1 and this is the point 2. Now, we assume that we have like temperature, humidity, wind speed, light intensity, four features. So what happens? It's the same, right? Get the difference between the temperatures, get the difference between the humidities, get the difference between the, and square it between the wind speed, and get the difference and square it between the light intensity, and get the square root. So this is how we are going to simply measure the Euclidean distance, and this is called the Euclidean distance. Right? Got it? So no matter how many features are there, it's like 60 features, 100 features, 200 features, no matter. You can still measure the distance, right? And how we are going to measure the distance like this and get the difference, get the distance between each and every data point in the training data and find the minimum one, which gives the minimum distance, and the label of that will be predicted as the label of the this thing, right? Got it? Understood? Right. Okay. I hope you understood, right? Okay. Yeah. So that's it. And that's the question. Now, in this case, can you tell me what would be the prediction? Yes, I will repeat it. Yeah. Okay. Now, before that, can you predict what the prediction? Just get the feedback and see, like visually you can see. So is it a red one? The nearest one is a red one or a green one? Red one, right? Okay, it's a red one. That means it's a rain day. But the next question, is it fair to do that? Is it fair to do that? Is it a fair prediction? Okay, so I got a message from the coordinator, the organizer. So he actually sent the thing with the different mail list, right? So he has sent it to the YouTube playlist. Not the YouTube, but the videos to a separate email set. So he told me that he will send it now, right? He will send it now, so you will get it now. Sorry about that, but I have already instructed to him yesterday. Yesterday after the lecture finished, I called him and informed, but he has mistaken your emails with some other group. So he just told me that he will send them now, right? So sorry about that. Sorry about the delay. I actually thought that you received those things. Sorry about that. But coming back to this one, the thing here that it's going to predict as a rain, but it's not fair, right? Why? Like, this is actually, in theory, this is called something outlier, kind of outlier. So that's like, okay, a rainy day, right? Around some no rain days, right? So these kind of things can be there, right? So rare cases. So in there, like with very high temperature and very high light intensity, with a sunny day, there can be suddenly rain, right? For 10 minutes. So you have seen this kind of situations, right? Sometimes a very sunny day, no sign of rain, but suddenly like 20 minutes rain might be there, right? So that kind of a day. So these are called outliers, right? Outliers. So deviated from the normal behavior, deviated from the normal behavior. But there is always a possibility to uh, cause, I mean, happen something like this, right? So there is always possibility to something to happen like this. But in this case, we are going to get a wrong prediction, and it's not fair since this is like surrounded by no rain, but suddenly there is outlier of rain data point, outlier data point for rain. So that will be given as a prediction. I mean, these are very rare. This is not going to happen frequently, right? This is not going to happen frequently, but this is very rare. And the thing is now, yeah, this might cause you some issues, right? Therefore, we have a method of overcoming these kind of issues, and that's where the K comes into play. Now, K nearest neighbor, that's the algorithm, not nearest neighbor. It's K nearest neighbor. So what do you mean by K? This is a user adjustable parameter, right? A parameter that the user can adjust when you are going to train the algorithm, right? When you are going to train the algorithm. So it's something like this. Now you can usually by default K is 1. K is 1 in the sense it's going to measure the, I mean, it's going to take the nearest neighbor, one nearest neighbor, right? But we can define this K to another odd number like 3, 5, 7. Likewise, we can assign it to odd number like this. Okay, let's assume like K equals 3. Then what happens? It's not going to select the nearest neighbor. Instead of selecting the nearest neighbor, it's going to get 3 nearest neighbors, right? 3 nearest neighbors. So what happens? It selects 3 nearest neighbors like this: 1, 2, and 3. So 3 nearest neighbors. And out of these 3 nearest neighbors, it's going to get the majority, right? Okay, now we have 3 nearest neighbor. So we are not going to get the nearest one, but out of these 3 nearest neighbor, we are going to check the majority, right? So now we can see out of these 3, we have 2 no rain days, right? 2 no rain days. Therefore, it's not going to give the priority to the nearest one, but it's going to give the priority to the majority, right? So in that kind of a simple uh, solution, we can overcome this kind of issue, right? Got it? So the K can be adjusted like that. Understood? The K can be adjusted, right? So if you go to the code, this is how we are going to change the K value. When you are getting the model, when you are loading the K nearest neighbor model, you can provide the n neighbors. Now, when you don't, if you don't provide the n neighbors, that will take the it by K. It's going to assume that K is equals to 1, right? So it's going to assume the K equals to 1. So it's going to measure the nearest neighbor. But else you can do it like this. Now, you may have a question. Okay, what happens when you are going to increase the K value? 3, 4, 5, 7. Right, so 3, 5, 7, 11. So is the accuracy going to increase when you are going to increase this one, or the accuracy going to decrease when you are going to do this? So that will be the question, right? That you have. But we can't exactly say what happens when the K increased and when the K is decreased, since that's something dependent on your data set. For different problems, for different data sets, it might be changed, right? So how we are going to then select what's the K value that you need to apply? There's a method called elbow method, but no need to use that kind of a very complex idea here. What you can do is usually you can work with K equals 1. That means without any issue, you can use the K equals 1. And like if you feel like the accuracy and the performance is a bit low, what you can do, you can change the K value to 3 and see what happens. It's also not giving you the good accuracy, change it to K5. Right? Likewise, if you are not like getting a good result when the K equals 1, the default one, you can change these things and see what it does to the performance measurement. So the only feedback you are going to get is the, like you are going to apply some known data and get the predicted targets, and with the actual targets you have to measure the accuracy. So that's the only performance measurement that you can get here, right? And the precision R2 score, F1 score, those can be also used, right? Similar methods, but I will explain about precision recall F1 score later. But the more major thing is the accuracy, right? So you can get it like this, and you will see that it's something like this, right? So then you can get a feedback which one is the best. So I can't exactly say which one K is the good, but it's always application dependent. Therefore, that's something that you have to do and you have to fine tune. Got it? Okay, so then this is it in a summary. So KNN calculates the distance, and according to distance to all training data points from the testing data point given, and it finds the k number of closest neighbors, by default k equals to 1. And then you vote for the labels. That means you are going to get the majority of the labels from the selected k value, right? From the selected k neighbors, the nearest k neighbors, you are going to get the majority, right? So that's how it's done. Got it? Right. I hope that you understood. Now, one of you asked to explain this again, so I will quickly go back with that one, right? So when you have two features, taking the distance between two data points is quite easy. What you have to do is you have to get the Pythagoras, right? So that means if this is like 60 and this is 35, and if this parameter, like what I'm referring here, is like, okay, y1, y2, x1 and x2, right? So then the distance will be simply x1, the difference between x values, and the difference between y values, right? And simply it will be the square root of this one. That's the distance, right? But usually we don't have always two features. We have more features, right? In that case, like if you have like four features like this, then you can't, like earlier we had only two, temperature and humidity, right? These two. So if you have those two, you know how to get the distance, right? So distance will be 37 minus 36. I'm talking about 2 points, right? Then 40 minus 60 and get the square root. But if you have four features or more than four features, what you are going to do similarly, you are going to get the squared difference, the squared error, we say the squared error or the squared difference between each and every feature, and add them up and get the square root. Right? Got it? Okay. Now the other issue, k nearest neighbor algorithm is not recommended for large dimensional data sets. What I mean by large dimensional data sets, so we have lots of features, like, okay, 1,000 features, 2,000 features, or like 500 features. When your data set has more features, right, higher dimension, then the KNN is not recommended for those kind of problems. That's something, some issue with the K nearest neighbor. It's not recommended for large dimensional data sets, like 1,000 features, 2,000 features, right? No, not recommended. Even 500 features, not recommended, right? What's the reason? Now, can you see that this always measures what? The square difference, right? The square difference, right? Now, it's going to get the square of the difference, right? Now, let's say here, okay, this is like simply like, okay, 1 squared, and this is like, okay, 10 squared, and this is like 5 squared. But here, what? A 50 squared, right? So what happens now? Let's say accidentally there is like a very big difference due to an outlier effect. Let's say due to an outlier effect, there is a, unexpected and unrealistic difference between two features. I mean, difference in one feature. Let's say light intensity. Since we are going to get the square of that error or the difference, you can see that error will be squared and added together, right? So it's going to give a very high impact. It's going to provide a high impact towards the total distance, right? Outlier, I mean, unrealistic uh, difference in a single feature, it's going to like square that error, and that will affect directly, it has a direct impact towards the total distance, right? Therefore, like when you have more features, right? When you have more features, what happens? Like, okay, you are going to add like the square difference of 1,000 features, let's say. There can be some features like with lots of, I mean a very large difference, right? Let's say that you have 1,000 features, so you have to add 1,000 differences and square them, and you have to add like 1,000 features, 1,000 values, right? In that case, like let's say that you have like 10 very large values, that's going to give a very large impact on this one, right? Now, if you can't understand what I'm saying, right? Okay, so let's assume some values for these things. Okay, now forget about this thing, right? Forget about this thing. Okay, temperature one is 37, and this is 36, and this is 40, and this is 41, right? And this is like, let's say 20 and 22, right? And this is something like, okay, something like 400 and 350, right? 350. So if you like assumed it, right? So one, so we are going to square them up, you know, right? Square them up, and here also 2, like that means 4, 6, and 50 into 50. 50 into 50 is what? 2,500. So it's like 2,000, right? This is the distance. Understood, right? But now, if you have something like this, let's say, okay, 37, 41, right? 40, and the humidity, the other one is like 46, and this is 20, and this is, let's say, the next one is something around like, okay, 25, and this is like 40, 400, and 410, right? 410. I'm taking two examples here, right? So this would be somewhere around what? This is 4. That means 4 squared. I mean, this is square here, square root, right? This is 4 squared, and I think yeah, 4 square of 4, and this is like a square of 6, and this is like a square of 5, and this is like a square of 10, right? And the square root of this one. So this will be something like the 60, 36, 36, 25, and 100, right? So what will be the value? 52, 52, 77, 1000, sorry, this will be 177, right? So earlier one is the square root of 2506. This is the square root of 177. But now you can see there is a very big difference in the temperature. There is a very big difference in the humidity, and there is a very big difference in the wind speed in the second case, which I wrote in yellow color, right? But earlier one, there are no significant difference between the temperature, humidity, wind speed, but there is a large difference between the light intensity. So that causes very large increment in the distance, right? Understood? So it sends, since the k nearest neighbor is sensitive to magnitudes of the features, it's not recommended for large dimensional data, right? So that's something you have to keep in your mind. So you are not going to use k nearest neighbor algorithm for large dimensional data set, right? Okay, got it? Right. I hope that you understood what how the k nearest neighbor works, right? Great. Okay, so now what we are going to do now, today we are going to move on to a new problem. We are going to develop a we are going to train a k-nearest neighbor algorithm for handwritten digit recognition, right? Handwritten digit recognition. So before going on to that, please give me 2 minutes. I will be back in 2 minutes. And meantime, you can go through this slide. So this is available in the Google Drive, right? The Jupyter Notebook. So we are going to train this digit recognition application. So I will be back in 2 minutes. Okay, so thanks for waiting and sorry about the delay. Okay, now what we are going to do now, we are going to develop this kind of um, uh, yeah, give me a second, I will show you. Yes, so this kind of small web application where it can identify the handwritten digits, right? Handwritten digits like this. So this is the application. Sometimes it's going to give you uh, wrong predictions, but this kind of a handwritten digit recognition app, right? So for this purpose now, this is how we are going to create the graphical, I mean this graphical user interface. I will explain each and every line of this one, and I will show you how we can develop this graphical user interface. But before going on to that, the graphical user interface is something else. That's we are going to use some library and create that graphical user interface. That's not the case. What we have to focus here is about the machine learning part, right? So how we are going to train a machine learning algorithm for this case, right? So we will now get to know how we can train a machine learning algorithm for this purpose, and then we train it, and finally we will implement it. We will integrate it with the graphical user interface, and finally create uh, the the graphical user interface I just showed you, right? Okay. So now we are going to deal with images, right? So handwritten digits are images. So therefore, we are going to deal with images. Therefore, we need to get a simple introduction about images in computers, right? So in computers, if you take images, there are three types of images that a computer can store. Three main, but other than that, we have some other images as well. But there are three main types of images: color images, grayscale images, and binary images, or black and white images, right? So the first one, you can see this is a color image, and this is said to be a grayscale image, and this is a black and white or a binary image, right? So what happens in the computer or in OpenCV or in Python? So we use mostly OpenCV for our image based applications, right? OpenCV library. As I told you, the OpenCV library will be used for our image processing applications. Now, if you take an image, so now a single element is known as a pixel, right? And pixel is simply a array, right? Sorry, not pixel. An image is a two-dimensional array in computers. So in computers, we can save an image as a two-dimensional array, a 2D array. In color, like it becomes 3D, but we will, for now, we will think it as a two-dimensional array which has rows and columns, right? So that means, since this is a 2D array, yeah, what's the image processing? Actually, the name suggests image processing. Like we are going to do lots of things with images, like process images and get some outputs like, okay, face detection, right? Handwritten digit recognition. So that's what those kind of applications involving the processing. Actually, that's what you call image processing, right? Dealing with digital images in computers, right? Okay. Yeah. So when you take a single pixel, right? When you take a single pixel, that pixel can be identified as a row number with a row number and a column number. For example, now this is row number 0, row number 1, row number 2, row number 3. This is column number 0, column number 1, column number 2, column number 3, column number 4, likewise. So therefore, this pixel will be identified as image 0, 2. That means, okay, 0 row, second column, right? 0 row and second column. Understood? Okay. So therefore, what happens, if you take a single pixel, according to the values stored in this pixel, we can divide the images into three main, as I mentioned, color, gray, and binary. So in a color image, what you have, if you take a single pixel, it has three components, right? Most of the times it's RGB. Some like HSV are there, like IUV is there. We have lots of color spaces. But if you take a color image, simply a color image, that color image contains three values for a single pixel, right? In a single pixel that you are going to find three values. Those are called B, G, and R, right? B, G, and R. So single pixel contain three values. For example, now these are BGR, or we can say RGB, but in OpenCV, the format is BGR, right? The format is BGR. So what it simply means, this BGR components are represented by 8-bit numbers in OpenCV, 8-bit numbers. That means each component, we have three components for B, G, and R, blue, green, and red, blue, green, and red. So each component is represented by an 8-bit number. So we have three 8-bit numbers here for B, G, and R. So you know a 8-bit number can hold a value between 0 and 255, right? 0 and 255. You know, right? 8-bit number can hold a value between 0 to 255. So what happens here? Now, using these three components, these BGR components, you can represent colors, right? So if you like have a color 25500, that means the blue component is like having the full value, and 0 from green and 0 from red. So that said the pure blue, right? If you have like 02550, that is green, B, G, R. B and R are 0. The G is having its maximum, right? And like here, you know, right? 255 from green and 255 from red. So green and red combined, that will be yellow, right? If you have 000, that means empty. No any portion from each BGR. So that's said to be empty. So empty color is black, you know, right? But if you provide like 255, 255, 255, that means that color is represented by full from green, full from G, full from red. So if you can like theoretically, somehow if you can mix the same compound, same amount from the pure red, pure blue, and pure green, you can make white, right? Yes, 255 means perfectly white. 255, 255, 255, that means perfectly white. And this is a intermediate color, right? 180 from B and 120 from G and 60 from R. So that's this kind of a brown color. So what it simply means, you can combine these numbers and that represents a color. Right? BGR combination can it simply represents a color, right? A unique color, a unique color. Okay, so the second type of images, a single pixel has only one 8-bit value, right? Only one 8-bit value. That means what? It has one 8-bit number. That means it can range from only 0 to 255. So grayscale images, 0, if the pixel value is 0, that means a black pixel. If the pixel value is 255, that means a pure white pixel, right? If you have anything in between those two, right? If you have anything in between those two, that would be a gray color one. That would be a gray color, right? So if the gray value is closer to 255, that's kind of a light gray. When it becomes closer to 0, that is a dark gray, right? Hope you understood, right? Then the last thing is the binary images. Binary images, you don't have that much of choices. You have only two choices, either black pixel or either white pixel. Either black, either white. Each and every pixel can contain only 0 or 1. That means black or white. So So that's what you call binary images, right? Binary images. Okay. So we have a question. Let's see. Okay. Uh, 02550. How it become green, right? Yes. Now the thing is, we have B, G, and R components, right? So each of it a 8-bit number, right? Each of it a 8-bit number, right? So yeah. So each of these components are 8-bit number in color images, right? So when you provide 0, like we can, that means 8-bit number, the range is 0 to 255, right? 0 to 255. So since B, like, okay, we are going to provide 0, that means no blue, no red, and full from G, right? So that's the pure green, right? So if you make this 255, that means what? Pure green and pure red. So what's the combination of pure green and pure red? You know from your, right, grade 1, 2 knowledge, that's the yellow color, right? So likewise, this is like the color combination, right? I think you can see these kind of examples. See, 0, 0. Now this is what something I found from the internet, right? So you can see it's the black well, right? So this is something I found from the internet just now. Let me show you, right? So likewise, right? So if you like have, okay, 55, 100. So this is something we don't know what's the value, right? So this kind of value, likewise. Got it? So now what I simply told you is about 0, 0, and 0, and 255, 255. That's, you can see the yellow. This simply becomes white, right? So that's the color combination, how the color combination works, right? So then actually not yeah, anyway, I think yeah, anyway, I think you can find similar example for that one. But anyway, gray, like simply 0 represents black, 255 represents white, anything between represents a gray, right? Okay, got it. Now you know about those things, right? So what you're going to do now, handwritten digit recognition, right? Handwritten digit recognition. That's our problem today. Handwritten digits recognition. That would become our problem today, right? So I discussed about this last time as well. So is this a classification problem or a regression problem? Now just assume that this is only detecting one digit at a time, right? Detecting one digit at a time. One digit at a time. Very good classification. How many targets? So we have 10 targets, right? We have 10 targets, 0, 1, 2, 3, 4, up to 9. So those are the targets, right? Very good. So that's what we discussed last time, 0 to 9. That means 10 classes, 10 categories. Okay, any idea about the, okay, now we have the problem here. So the labels are also defined. Do you have any idea about the features? What would be the features of this problem? Guess of yeah. Okay, right. Okay. Uh, okay. Again, sorry about the disturbance. Right. So there's some technical issue, but I hope that won't be happening again, right? Okay, so the features, yes, the answers given by most of you are correct, right? The pixels, the numbers, that means the pixel values, right? Yes, that's exactly what becomes the features, right? So if you take a digit, the pixel values of this feature, I mean the pixels values of these images will be taken as the features. So to be exact, the problem that we are going to do, the data set that we are going to use today has 8 by 8 images, right? That means the resolution 8 pixels by 8 pixels. That means how many features will be there? Yes, gray pixels, exactly, gray pixels. So the images that we are going to use today, they are having like 8 by 8 images. That means 8 rows and 8 columns. So how many features will be there for a single image? Any idea? Okay, 7, 8. Actually, what I meant was like, okay, we have 8 by 8 images today. Each image, I'm talking about each image is a 8 by 8 image. So in 8 by 8 image, how many pixels will be there altogether? How many pixels will be there? 64, right? So that means how many features? 64 features. Yeah, 64 by 3, no, but the thing is we are not going to use color images. They will be gray images. There will be so one value, right? So there will be only one value in a pixel. We are using grayscale images. So there will be only one value in a single pixel, or one value in a single pixel. So we have 8 by 8. That means we have 64 values, right? We have 64 values. Right? We have 64 values. So we have 64 features in that case. That what it means, right? Got it? Okay. So fortunately, now features will be the pixel values of each image. Fortunately, we have a data set, an inbuilt data set. This is provided by the scikit-learn library, right? So there's an inbuilt library provided by scikit-learn for handwritten digits. So we can use that library and train our algorithm, right? So in order to load that algorithm, load that data set, we have to use this load digits function. So from sklearn.datasets, so there is the scikit-learn library. We used this last time as well. Scikit-learn library. From the scikit-learn library datasets, we are going to import a function called load digits, right? So this load digits function can be simply used to load the data set uh, uh, load the digits data set. So what happens when you call this function load digits, it loads the data set into this folder, right? Now here we are using an inbuilt data set, a data set provided by the scikit-learn library, right? So in that case, we can directly get it from here. We can directly get it from the library. But when it comes to our own images, when it comes to our own data set, this is not how we are going to do it, right? So tomorrow you will see a good example. Tomorrow we are going to build up a face recognition algorithm. In that case, we use our own images, right? That in that case we use our own images. So when you use your own images, you have lots of steps to follow. You have to load the data set, you have to pre-process the data set, you have to resize, you have like, that's what I mean by pre-processing, and then only you can create the data set. You have to create your own data set, and finally you have to apply it to the machine learning algorithm. So when you use your own images dataset, there are lots of steps involved. But here today we use a inbuilt dataset given by the scikit-learn. So we just have to call the function and load the dataset. But in the real case, when you are dealing with your images, it's not the case. So that kind of example is scheduled tomorrow. So you will get to know how you can deal with your own images dataset tomorrow. But today we will just use this inbuilt dataset, right? Question. That is, sorry, this is a method actually. Load digit is a method, sorry about that. Now we can load the dataset here, and this dataset contains three things. The data, you know what data, right? Data, and the target, you know, data and target. Data is the feature, target is the label, right? And images contains the 2D version. Now there's a special thing about this. This images is the 2D version of the data set. This data is the, this is the 2D version of the features, and this data is the 1D version of the features. I will show you. Now we can load this into data from the data set. We are going to get the data and load it to data. From the data set, we are going to get images and load it to images. From this data set, we are going to get the target and we are going to get it to the target. So when you print it, the shapes of them, right, that means the sizes. So it says the data shape is 1797.64. That means it has 1797 columns and 64 rows, right? Image shape, the shape of the image is 1797. It has 8 by 8, right? So now I will explain what is there, right? And then the target. Then the target is simply 1797. That means a one-dimensional array, right? So let me explain. Now I'm going to get the matplotlib library. Now I'm sorry about this. Now I hope that you got the videos last time. So please go through that videos. It covers everything about MATLAB, everything about NumPy, everything about the introduction to OpenCV, NumPy, and Matplotlib, as well as introduction to Python as well. So I hope today you will get it and you can go it through that. So you will cover these basics and you then get to know, right? So this says, okay, we will start from the images. Images, it says, okay, it has 1797 8 by 8. So this simply means it has 1797 images of 8 by 8, size 8 by 8, right? 1797 images of 8 by 8, the resolution 8 by 8, right? So now we have 1797, right? We will check the first one, right? So I'm going to show it using the matplotlib. There is a function, a method called imshow. So we use this imshow method, and I just try to plot the first image of that data set. And I'm using like the gray color map. CMap gray simply says, I did use plt.show as well. Okay. Right. Yeah, exactly. 8 by 8. Right. So that means, okay, out of this 1797, I'm just showing you the first image of that one. We have 1797 images of 8 by 8, right? So you can see 8 rows and 8 columns, right? 8 rows and 8 columns. Okay, so this is the 100th one. It's a 4, I can't exactly see 4. It's in bit, it's in low resolution, right? 8 by 8. So let's check the 1796, since it's going from 0 to 1796, right? This is the last one of the data set, right? So actually, if you print it, you are going to see this one. See? So these are the features. The 64 numbers. So these will be the features, right? These will be the features. Understood? All right. So let me show you the 0 image. Okay, the image number 10, image number 10, or image number 20, let's say, image number 20. So this is the image number 20. you can't get the feedback here, right? So you can see the colors, but you can see some numbers, but you can't see what you can check what is that, right? Yeah, I will explain that. Okay. Now, so let's see the target of this one. Target simply says what this digit is. What this digit is. Okay. So this is the 20 image number 20, and target 20 simply says what that digit is, the label. So it says it's a 0, right? So if you like, okay, the 100, let me plot the 100th image. So I think it's a 4, right? 4, 9, 4, I think. So if you print the target of the 100, that is, says it's a 4, right? So then images contains what? The 8 by 8 image, so 1797 8 by 8 images. And the target contains, I will discuss about the data later. Target contains what? The corresponding labels of each and every image. The corresponding label of each and every image, right? Okay, so this is the 100 image and this is the 100 target. That means it says it's a 4, the label of that image. Understood? Target is a variable, target is an array, right? So now actually what it means, data is 1000. So the data dot shape simply says how many rows and how many columns are there. How many rows and how many columns. So these are assigned to arrays. These are arrays, right? So the dot shape, using dot shape, you can simply check the size of it or the dimensions of it. Now data dot shape simply says, okay, it has 1970, so 1797 rows and 64 columns. I will explain about data, I told you. But this says 1097 88. So that means 1970 1797 8 by 8 images. This 1797, so that simply contains the label of it. So this is a 1D array, right? It's a 1D array, right? Okay, so now you can see this is the 2D version. 2D version in the sense, okay, 8 by 8. So these are 64 numbers here. So this is the actual image you can see. This is the values of it. When you print it, this is the value of it, of the 100th image, right? So what we mean by data? Data, what actually data contains is the flattened version of this image. Now this is the 2D version now. So this contains the flattened version of this one. What do you mean by the flattened version? No, target is not is stored in a dictionary type. So let me print you like, okay, so the first 100 value of the target, I think we can't see all one, but I will show you the first 100 values of the target array. Okay. So it contains, okay, this says, so the digit number 1 is a 0, digit number 2 is a 2, digit number 3 is a 3, 2, likewise. Got it? It's an array, just array. Type target, okay. This is a numpy array, to be exact. This is a numpy array, not a dictionary, right? Numpy array. It's a numpy array, right? Okay, so anyway, the data, right? Actually, data contains the flattened version of each and every image. So how the flattening is done, what you are going to do, each and every row is taken out and you are going to create this kind of a row vector. You are going to create this kind of a row vector, right? A row.
Hello?
Yes.
Hello? Just a
Yes,
second.
Krishna.
So
Yes.
you are going on saying about these topics, but actually when we were said about this course, they said that you will be starting from the basics.
Okay.
And you said that you will be providing basics yesterday, but we didn't got basics till now. And
Yeah.
without basics going on saying, then what we will understand within a 5-day course?
Yeah. The Krishna. Now the issue was, I think, did you attend now or you were there from the beginning?
I was there from the beginning, sir.
Okay.
Yesterday I
Right.
understood a bit because it was a theory one. But now
Yes.
you're going on saying about modules, all
Okay.
this. I couldn't get them all.
Yeah. I got the point. But the thing is now, as I now actually I'm just doing the I mean the lecture here. So there is a organizer for this kind of workshops, and there is a like everything is done by them. So what I told them to provide you the, I mean, they told that they have mentioned that they need the basic Python knowledge, right? They need the basic Python knowledge, and the other thing is that means that we are going to assume that you have the basic Python knowledge as a requirement, right? So that was advertised, and the other thing is yesterday I actually asked him now when I got to know that you don't have the basic Python knowledge. When I got to know that, I asked him to send you the videos, right? So that's not something done by me. I don't have direct access to your emails, or I don't have direct access to your WhatsApp numbers or WhatsApp groups, anything, right? So what I'm doing is I'm just doing the lecture. So I'm just sending the invitation to this Zoom link. So he's coming. I mean, you are logged on here. So I'm doing the lecture. So I just can provide the materials to the coordinator, right? So I provided them all. And yesterday, actually, I asked him to provide the basic videos. Actually, before this workshop starts, I have prepared some basic tutorials for you, like the Python things and everything, the modules and everything, right? So I assume that yesterday you have got it, but unfortunately, it's something from that the coordination part. So I'm very sorry about that, but I asked him to send it to you. So I'm sorry about that. So you will get it tomorrow. I mean today itself, right? Sorry about that. And the thing is, otherwise I can't like spend time on explaining them here. Then the thing will what happened will the time won't be enough to explain whatever the content that we have uh, scheduled. Yes, I accept that it's something from actually not my side, but I'm also in the this side. So yeah, I accept there is this kind of a issue, right, from your side. So from our side, right? So I'm extremely sorry for that. So anyway, you will get the videos today. I can make sure that, right? So I just like in the meantime in the lecture I asked him about this, what's the issue. So he accepted that he uh, couldn't able to send these things yesterday. So unfortunately, uh, nothing to do. But anyway, you will get it today, right? So sorry about the issue. So you can go through that, right, and get them covered, right? So I'm extremely sorry about that. But anyway, now we will continue, and otherwise. The thing is, we can't cover the whatever the content that we have scheduled, right? Therefore, very sorry about that, and uh, you will get it today, right? So nothing to do about that than that, right? Okay, so other thing is there's another requirement in the, as I know, right? So I exactly don't know is this the real case, but as I got to know that you need the basic Python knowledge as advertised. The basic Python knowledge is required. I'm not sure that whether that kind of issue is there, or I mean that kind of advertisement was there or not. But anyway, that requirement should be there, the basic Python knowledge. But modules, uh, that's something we have to provide you. But anyway, you will get it today. Sorry about that, right? Okay, so what happens? The data simply it is flattened, right? It's flattened. That means what? Whatever the given 8 by 8 image, right, will be flattened. And how the flattening is done, you are going to get the rows, right? I mean, each and every row, and those rows will be uh, arranged as a one-dimensional array, right? It will be arranged as a 1D array. So finally, what we are going to get is a row vector, one row vector, right? So that means 8 by 8 becomes 8 by 8 2D becomes 64 1D. Got it, right? So that's what they are in the data, right? That's what they are in the data. So that's why you are going to see the shape like, okay, 1797, 64. So that means each image is 8 by 8, but the data contains the flattened version of those images, right? The flattened version of those images. Got it? Since the issue is now we can't apply a two-dimensional feature, I mean, the data set as 2D when you are going to apply it to a machine learning algorithm, right? You can't apply it to a machine learning algorithm in 8 by 8 form, I mean the two-dimensional form, right? So you have to definitely convert it to a 1D before applying. But now I told you that this is something that we are doing for uh, inbuilt data set. That means a data set already available in the scikit-learn library, but now they have provided these things. Now you will get to know about these things tomorrow, since tomorrow we are dealing with our own data set. So in that case, we have to do everything manually. This flattening, this conversion to 1D, right? Everything should be done by ourselves. So then actually we are going to get the real experience. But today we will use some already available data set, right? Okay. So yeah, then what we are going to do now, you know, the data set is there. So what we are actually using is data and target. I just got the images to show you how the images behave, right? How the image behave, that's 8 by 8, but actually we use the flattened version of it, right? We use the flattened version of it, right? The flattened one. That means 64, 1797, 64, right? Okay. Yes, so what we do here, simply you know the splitting, train test splitting. So let me run it from here. Yeah. So what we are going to do, okay, the data set will be split into training and testing. So you know this function, we used this yesterday as well, right? 0.2 for 20% will be there for testing, and the remaining 80% will be there for training. So approximately how many images will be there for training? Any idea? Yeah? Any idea? How many images will be there for training approximately? No, not 9. I mean training. So how many images are there? Yeah, yeah. How many images are there for, I mean, altogether, how many images? How many images will be there altogether? I told you, right? 1000, no, 1797 images are there, right? So that's what they are in the data. Each image has 64, right? Each image has 64, right? Yes, exactly. Now we have, now this is what the data shape says, right? 1797, each image, like these are the number of images and these are the features of each and every image, right? So it's simply, now we use 0.8, that means 80% for testing. So that will be 1797 into 0.8 simply. So this amount of data, right? So roughly 1438 will be there for training, right? So testing, the remaining 359 for testing, right? So then what we have to do? Okay. Ah, right. Get the algorithm. Yeah. Now this shape, right? Okay. So this is what? Okay. 1000. Now, like the shape actually gives you, for example, now, actually, sorry about this. This is there in the NumPy, I mean, module tutorial, but anyway, let me create you a simple array and show you. Now, don't worry about this random. I'm just creating a random array to get some values to show you, right? Okay, so this is just for example. How many arrays are, how many values are there? How many rows and how many columns are there? Right? Okay, yeah, I will explain now. How many values are here? How many rows and columns are here? How many rows and columns are here? Five and three, right? Exactly, 5 and 3. So array.shape simply gives you, see, the number of rows and the number of columns, right? When it's 2D, right? When it's 2D, right? When it's 2D. But if you have something like this, now don't worry about this, what I'm doing here using this random integer, don't worry about that. Just worry about this array and so here it says, right? So we have only like one dimensional array. So it says, okay, this is a one dimensional array with 5 elements. Right? Got it? So the array shape, simply the array dot shape, simply provide you how many rows and how many columns. That means the dimensions of it. Right? Dimensions of it. Okay. Okay, how many dimensions are here? Can you guess? This is a three-dimensional one, right? How we are going to identify it as a three-dimensional one, right? Okay, so here you can see the large, I mean the outermost thing is there, right? So then you have like, okay, here, right? So 1, 2, 3, 4, 5, 5, and in each 5 you have another 3, 1, 2, 3, and each of that you have two values, right? So this says it's simply like 5, 3, and 2. So it's a three-dimensional array, right? I mean, you can't visualize it here, but actually these values are like this. 66, 44, 41, 89, 17 to 27. And like behind this, you have, okay, 89, 56, 90, 78, likewise, right? So it's like the third dimension, right? It's like the third dimension. Now, don't worry about these things. Anyway, what I wanted to show you is that the array.shape simply gives you the dimensions of the array, right? How many rows and how many columns and how many dimensions are there. That's what it simply gives you, right? So therefore, what this gives you, which one? This one. So it says, okay, 1797 rows and 64, right? So that means that you have 1797 rows. And how many columns? 64. That means like one row represents one digit. One row represents one digit And for each digit, you have 64 numbers. And this is the second digit. The flattened version of this, right? So finally you have 1796. Got it? Right? And this is the data. So what target says simply, what target says, what this digit is. Okay, this is a 0, this is a 2, this is a 5. Understood? So target also has 1796 values. Got it? Got it? Understood? Yeah, target is 1D. Target is 1D. Target is not 2D. It's only having one value, so it's 1D. Target is 1D. Right? The thing is actually you asked me to print the data. Unfortunately, it's not visible since it has 1797. It won't visible, but you can see some of them. Right? Let me print you the first 10 of it. The first 10 of it. You know, first 10 rows, all columns. I explained you this last time, right? First 10 rows, all columns. Right? So this is the digit number 1. This is the digit number 2. This is the digit number 3. Likewise. So altogether we have 1796. Got it? Got the idea? Fine. Comfortable with that? Now it's not shown in the same line, but there are 64 now. This one square bracket marks one digit, right? Okay, understood? No, but unfortunately not. You have the thing is you can't visualize it in the Jupyter notebook. But if you use the spider in Anaconda, you can probably print it, the whole one. Right? Okay. Right. Yeah. Yeah, you can, yes, exactly. You can write it as a CSV file and see the numbers. Yes, you can do it. Right? Yeah, so that's it. Then what you do? Those data 1797, 64. So 64 is the number of features, 1797 is the number of data available. So we split it to 20% and 10%, right? So the training is done. So thereafter, what you do? From sklearn.k nearest neighbor classifier, we get the k neighbors classifier and we train it, right? Can you remember that I told you I told you something last time, right? So if you want to change the algorithm, like, okay, now I will discuss about the support vector machine tomorrow, but this is how we are going to do it using the support vector machine. Only 2 lines will be changed in the code, but the working principle is different when it compared with KNN and SVC, support vector machine, right? It's quite different when you compare with the SVM and the K nearest neighbor, but in the code, you have to change only 2 lines like this, right? I just wanted to show you here. Don't worry about the SVM. We will discuss about it tomorrow, right? Okay. Sorry, not this. It's just a comment. This is the thing you need to import the library, right? So then we train data, train target. Like yesterday, we train it. Then what we do is here you can see the size of the train data and the test data. So 1797 now is split to 1437 and 360. 80% to 20% ratio, right? Okay, so finally like we are going to test the algorithm as we did yesterday. So we apply these 360 images, right? So we have 360 training images to the algorithm, right? And then what it does, simply it gives some predicted targets. So we print the predicted target and the actual targets, right? So these are the the 360. I mean, these are the actual target of those 360 images, the 360 testing images, right? So these are the actual targets of the 360 testing images, and these are the predicted targets of those 360 images, right? Got it? So then you know how to measure the accuracy, right? So we measure the accuracy. Now it's giving us more than 98% accuracy, right? We can, you know, that it gives us 98, so good accuracy, right? Now this is a very good thing since we have used like around 1009, yeah, or around like near to 1500. So we have a large data set, though still it gives you 98% accuracy, right? So this is like what we apply 360, right? Something, yeah, 360. So from 360 predictions, it says it gives you 98% accuracy. So that means 340, 355. 355 is correct. Um, yeah. So okay. So there's a question. Can I explain about all the arguments? Not exactly now, but since the time is not enough, but I will provide you the you can do these things. Now you have the basic knowledge, right? So I will show you where all the details are available, right? So you can go to let's say scikit-learn KNN, right? So this actually this takes you to the official documentation of the yeah, not this one. Yeah, here, see. So it actually, now you can use the scikit-learn official website. So it explains about everything, right? It explains about everything. So all the parameters and everything, each function, you got to know about these things, right? So please visit this, and you can do it for if you want to know about the support vector machine, search about SVM, and it will again provide you the information of the SVM as well. Not available. Let's say support vector machine. Yeah, sklearn.svm. Likewise, all the data is available in the scikit-learn official site. So you can probably visit there and read about these things, right? Okay, so let me provide you this one. So this is like a kind of a, user manual. Right? It's like a user manual for you all to get everything, get to know about everything about these the arguments and everything, right? Yeah, Ravi. Now, actually, that's what we are going to do now. Now, okay, done. So the training is done, getting a good accuracy. Finally, how to now? I mean, we can't always train it using the Jupyter notebook, and we can't always train it using. Do it using this Python uh, code, right? So somehow we have to integrate it to a web application, mobile application, PC application. Somehow we have to take it out from the Python, right? We can't always do with Python. Yes, when you are going to train it, when you are going to test it, when you are going to evaluate it, when you are going to optimize it, right? In that case, we will use Python for the machine learning model development. Machine learning model training, optimization, evaluation, all the things we use Python. But there's a limit. After optimizing, training, and everything is done, after testing is also done, that ends the Python, the role of the Python, right? That ends the role of the Python. So this is the last step. You can save this trained model into a physical file. And the importance of saving this into a physical file is that this can be used in any other environment, like, okay, a mobile application or a web application or a PC application, anywhere, right? So this is the model that you need to save in order to use it somewhere in any other platform. It can be written in JavaScript, it can be written in like front end in HTML, right? Back end in Node.js, right? Or React Native, anything, right? So if you want to get these things and integrate these models, machine learning models, deep learning in web applications, this is how we are going to use it, do it. You have to first save it here, right? So what happens, this library joblib, right? What you can do is simply go to the Anaconda prompt. Now, last time I told you how to do this. Go to the Anaconda prompt. I'm not sure, actually, I can't exactly remember whether this joblib is available as inbuilt library, but right. But if it is not, what you can do is use the pip install joblib, right? Joblib. So what simply this does, the Anaconda prompt. So pip is the Python package installer, Python package installer, Python package installer. So we ask to install this joblib library. So these are external modules in Python, right? External modules in Python. So what you can, what happens actually, this will be downloaded from the internet and save it in your Anaconda, in your environment, right? So everything is done automatically, right? Everything is done automatically here. No need to do anything. Once you run this code, it goes to the website. Now, in my case, it's already installed. So it will be download it and install it in your computer. That's what happens, right? Okay. So you can use pip install joblib in order to install these external modules, right? Okay. So we save it to a physical file. So what happens here simply, if you go to the working location, right? So this is the file that saved here, right? The file saved here, got it? Okay, now it saves the train file into a physical file, the train model into a physical file, right? The extension that you are using to save scikit-learn models, no matter what's the scikit-learn model, it can be support vector machine, k-nearest neighbor, clustering algorithm, anything. If that is a algorithm of scikit-learn library, you use the SAV format given by the scikit-learn, right? So that's the format that you are going to use. So this is the algorithm, and this is the physical file name, right? The physical file name, right? Okay, so then what you can do is you can get that model into this kind of right. So then you can get uh, this into this kind of a graphical user interface and get predictions, right? Got it? Understood? Right. So then what we are going to do now, yeah. So what happens actually, this is going to save this file, right? Then you can load it in your application. You can then load it into your application. I will show you. This is how to save it, right? This is how to save it to a physical file. Now, actually, you can't save, I mean, you can't view it inside, right? You can't view it. So if you try to view it, you are not going to see anything. So it's kind of an encoded thing, right? So if you like, okay, this is the file. So if you open it using like any other developer, it's kind of an encoded thing, right? So saved in like hexadecimal format. So this makes no sense for you. We can't read it, but unfortunately, it cannot be read. But what's what they are inside, you can't read it. But we can use it in any other codes, right? We can use it in other codes. I will show you how to do that, right? Okay, so yeah. Um, right. So now what we are going to do, we will use right. So now what we are going to do, we will quickly develop this kind of uh, graphical user interface, right? This kind of a graphical user interface, which has 4 buttons and this kind of a canvas and this kind of a label, right? So for this purpose, we are using the tkinter module, as I um, okay, right. So right. So can you all give me a okay. So can you all give me a second? I will come back, right? Okay, can you hear me? Can you hear me now? Okay, give me a second. I will get the video. Right. Um, Right. Okay. So sorry about the delay. Now I think it's fine, right? Okay. Right. So now we have saved the model. So what we are going to do now, we are going to load this model into our code and create a nice graphical user interface, right? So this graphical user interface development will be done using tkinter, right? So this is tkinter is a standard library coming in Python for graphical user interface development. It's an inbuilt library for Python. An inbuilt library, that means it's a standard library, its standard module comes with Python, right? So let me quickly build up this module with you, right? So I'm going to get a new code, and in this new code, first you have to import the tkinter module. So it is done using import tkinter as tk. So this simply imports the tkinter module. And the first thing then you need to do is create a main window, right? Create a main window. So that can be done simply like this. So tkinter library, we got the tkinter library as tk to our code, and now tk.tk. So this simply creates you a main window. So let me show you. Uh, the thing is, now once you get a main window, you have to run it. So that running can be done using win.main loop. This is running the GUI, right? Running the GUI or the main window. So if you do this, you will see what? This kind of a window, right? So this is the graphical user interface that we have created now. Okay, so this is how simply you can create a graphical user interface in Python, but we haven't had anything here yet, right? We haven't had anything yet, but this is the simply how we are going to create a empty graphical user interface in Python using tkinter, right? You are going to create a new window, and this can be anything. I mean, it's a customized name. You can give anything here. That's a customized name. You can provide anything here, right? The GUI or anything you like, right? Whatever the thing name you like, right? Then that method should be called GUI.main loop. So you are going to create a GUI object and GUI.main loop. You have to call the method to run this GUI. Now, this is the first part, creating a main window. And then what you have to do is add widgets. Then that's what we are going to do, add widgets. So what we mean by widgets, there are lots of widgets available in tkinter, right? So there are lots of widgets available in tkinter. So let's search about tkinter widgets, right? Tkinter uh, widgets, right? Um, Not a list available here, right? So tkinter buttons are available, canvas, frame, labels, scroll bar, list box, these kind of uh, list box and check buttons, radio buttons. So there are lots of things available in tkinter, right? Lots of widgets we can use, like these kind of buttons, like selection buttons, scroll bars, right? So lots of widgets available, right? So what we are going to do is, now we are going to create not all, but what we want. We are going to get what we want. So if you go back here, you can see that we need a canvas, right? So we need a canvas. So therefore, we will add the canvas here first. So how we are going to add the canvas? Simply in tkinter, what you can do is simply get a canvas like this. Okay. So what I do here, simply I'm going to create a canvas, right? And that canvas, the first parameter when you are going to create, okay, tk.canvas, tkinter library, you are going to create the canvas method. So when you are going to call the canvas method, you have to pass the first parameter where this canvas should be placed. So this canvas should be placed in the main window. Then we have to provide the width, and then we have to provide the height, and then the background color. So we provide the background color as white. So we have to provide the W and H. So W and H, let us provide like 500, 500. So that means height and width, right? So then we have created the canvas. Then the next most important thing is that you have to place it, right? You have to place it. So I'm going to place it using the, I'm going to call a method in canvas object called grid, right? Grid method. So what happens, you have to provide in which row, in which column the canvas should be placed. And this column span, I will let you know about the column span in the next step, right? For now, just take this idea. Okay, this canvas will be placed in the row number and the column number of your main window, right? Let's see. Okay, so there is a canvas now. You can see a white color canvas. So if you use any other color, like let's say now, in tkinter, the most important thing that you can provide the colors in their names, right? In their names, like no need to provide hexadecimal or BGR values. You can just provide the color in the name. So these are the colors available in tkinter. You can search about tkinter colors in the internet, right? So these are the set of colors available. So you can use any of these colors as a name, right? So you can have like, right? See, you have like cyan, pink, gray, right? Likewise, you have lots of colors. So you can search about these colors in the internet, tkinter color. So you will get the full color list, right? So we have lots of colors available, right? In tkinter. So you can just provide the name. For example, pale violet red. So you can write it like that. Pale violet red. Right? Understood? Okay. So yeah. So then I will use the white color since I need the white color, right? I need the white color. Uh, so what I'll do is the canvas is now done. So then what are the elements to be added? You have to add these 4 buttons, right? 4 buttons. So let me add those as well. Simply you can let me add one button here. Yeah, button save. I will add the button save quickly. Button save, right? Button save. I'm going to create a button object called button save, and it's a tk.button, and it's placed as the similar k earlier. The window that where the button should be placed, and the text of the button, and the background color of the button, and the foreground color of the button. That means the foreground in the sense the text color, right? Then you have to provide the font and the command. I will explain later. No need to have the command now. Okay, so we have lots of questions. Yeah, the grid simply, now you will see. Yeah, we have to provide the button fonts as well. So let me provide the button fonts quickly here. So I have declared something called font button Helvetica 20 bold. So this is like you have to mention uh, the font type and the font size, then whether it's bold, italic, or underline, right? Font name, font size, and bold, italic, or underline, right? Okay, so right, understood. So now you can see, right? So in the grid function, what we are going to provide is the column number and the row number, right? The column number, okay. So you can see, okay, this is the it's saved in the column 0, I mean, the canvas is in the column 0 and row 0 and column 0. So this is in the row 1, the next row, and the column 0, right? So that's what it use as row and column grid function. You have to provide the row number and the column number where you are going to place uh, the widget. So this is a widget, this is also a widget. So grid simply place it in your window, right? Got it? So then similarly, let me add the other buttons as well. The other buttons as well. The other 4 buttons, right? The save button, predict button, and clear exit button. So you can see the same row but different columns, right? Same row but different columns, right? Row 1, row 1, row 1, row 1, but column 0, column 1, column 2, column 3, right? Understood? So yeah, let me remove this command. I will explain what I mean by command later. Right, so see, now the buttons are also added. Right? So when you are adding the button now, nothing happens when these buttons are pressed, right? So I just create the interface. That's all. No functionality is done yet. I have just created the appearance. There's a canvas and there are 4 buttons, right? So now one parameter that I want to explain here. Can you remember now? These are known, right? The text of the button, the background, the foreground, and the font of the button, right? It's Helvetica 20 bold, this, right? And the first parameter will be where to save it. And the placing is done using the grid, button.grid. So it does the placing, right? Okay, so now if I remove this column span, what happens? You will see the column span. I removed something from a column span from the canvas object, the grid. Right? So you can see this kind of a weird thing is appeared. Right? So what is the meaning of this now? It has taken, okay, column 0 and this is column 1. So this is like, right? This whole region is now considered as column 1. Sorry, column 0. Right? So we placed it in the row 0, column 0. Now what it does is it gets this length of the canvas as the dimension of the row 0. So that means, okay, the button 2 is also in the row 0, right? But column 1, right? Column 1, row 0. So you can see button is somewhere like it takes all this width, width, right? Understood? Got it? So that's what if you don't use a column span, right? So what happens when you use a column span, this keyword column span, what the column span simply does here, it just, now what do you mean by column span? Okay, that means under this object, under this canvas object, keep space for 4 columns. That means from, the row 1, right? Row 1, right? Row 1, the length of the, the length of the canvas, right? Divide the length of the canvas into 4 columns in row 1. Understood? So now what happens here? Okay. So this length of the canvas, the width of the canvas is now divided into 4 at row 1. This is row 1, right? This is row 0. Right? So that's what happened in this column span. Okay, so next what we have to do here, we have to add this kind of a label, right? Label to show the predicted digit. Right? So what I'll do quickly, let me add that as well here. So in the window, we are adding a label and the text is predicted label, predicted digit none, in the background color white and the foreground color black, right? And the font is Helvetica 24 bold. Okay, now everything is done. Perfect. Now the appearance of the GUI is done. Now we have everything here, right? We have everything. Now we need to quickly write the functionality of this one, right? So before going on to the functionality of this one, now don't think once you create a canvas, we can't draw anything here, right? So we can't draw anything. This is just a canvas. We can't draw anything here, right? So that drawing function is also should be uh, developed or should be included by us, right? So we have to give the functionality, the drawing functionality should be given by us, right? So how we are going to do that quickly is this one. Okay. So this is like this, okay. This is the canvas object, right? So you can remember. This is the canvas object. So I bind it. There's a function called bind. And this is the binding function or the binding event. Binding event. And what happens? This is the function to be called when this binding event occurs, right? Now don't get confused here. I will show you what I mean by this binding event. But let me create a function called event function. Event. It's a like customized name given by me. No need to have the event function. You can use any name as you want. Right? So let me add some other parameter called event here. I will explain all of this. Sorry, print called. I'm going to add the print called. So what happens whenever this function is called, it prints called. Right? Right. So now what happens? Whenever the function calls, right? Even function call will be printed, right? So let me quickly show you now. There are lots of examples for this now. I'm not going to like go in detail about this tkinter thing, since the tkinter graphical user interface is not our focus. Our focus is machine learning. That's why I'm explaining this quickly, right? Anyway, tkinter bind functions. Tkinter event binds. Yeah. Now this actually gives you a good explanation about this event binds. Right. So what we have like lots of event binds, right? Button, motion, button release, double button, enter, leave, focus in, focus out. Likewise, we have lots, right? So let me show you the full version of this one. Right. So for example, okay, button, this is an event, button. A mouse button is pressed with the mount point or the widget. The detail part specifies which button. Example, the left button is button 1, the middle button is button 2, and the rightmost button is button 3. Okay. What happens? A mouse button is pressed with the mouse pointer over the widget. Okay. Let me go back here. And I'm going to change, okay, not B1 motion, but button 1. Button 1. And let me run this. Now, you have to keep in mind what happens in the bind function if this event occurs in this widget, inside this widget, this function will be called, right? This is what bind does. This is a event. If this event occurs inside the canvas object, this function will be called. Then you are going to see event function is called, right? So let me run this and show you. So I press the mouse. I press the mouse inside this canvas, right? Nothing happens when I press something, I mean, in the label or the buttons or anything, but when I press it inside the canvas, the function calls, the event function calls, right? So then, I mean, so what happens then? Button one, as it says, a mouse button is pressed with the mouse pointer over the widget. Right? So we have to press the mouse inside that widget. Right? So button 2, if you put button 2 here, that means the scroll button. Now here nothing happens when you press the left button, right? Nothing happens when you press the left button. When you press the scroll, this happens, right? Likewise, so here also button 3, now the right button, right? So now nothing happens when the left button or the scroll button is called. Now everything happens when the right button is called, right? Okay, so thing here that we need to do is not that, but we want this one. So you can read about this. I will send these references to you all, right? You can read about these things. Now what I want is this motion. The mouse is moved with the mouse button being held down. That means once the mouse button is pressed, and if you move that mouse button inside the canvas, okay, then this event calls, right? To specify the left, middle, and the right button, B1 motion, B2 motion, B3 motion, right? Okay, so we will use B1 motion. Okay, so now nothing happened when I click, sorry, right? So nothing happens when I press anything. But if I press it and move, then the event function is called. You can see, then the event function is called, right? Right? So what I have to do is now, when I press the mouse and move uh, the mouse, the button being held, right? So this happens, right? Okay. So what we are going to do now is simply now what we have to do is, okay, when we move the button, the press the button and move it here, we have to draw something here, right? We have to draw something here, right? And this event passed here simply gives, you can get the event dot x and event dot y. So what do you mean by event dot x and event dot y? That means when this event function is called, this simply says the x coordinate of the mouse pointer and the y coordinate of the mouse pointer. So let me show you some. Right? So it gives now, okay, what happens if I move somewhere here? So it should be like close to 0, 0, right? So let's see. Yeah, right? So you can see it's quite close to 0, 0, right? So this actually like x and y is given like this. So start from here. This is the x and this is the y. Right? So this is 0, 0. Right? So x and y provides us the simply the x and y coordinate of the mouse pointer, x and y coordinate of the mouse pointer, right? So now what I'm going to do, okay, we are getting the x and y. So I'm going to take it into like this, event x and y is taken into event y, right? Event x and event y. Then what I'm going to do, I'm going to draw like I'm going to do something like this. Uh, um, So I'm going to create, let me make this like this. Okay, x minus 30, x2 is x plus 30, y1 is y minus 30, y2 is y minus sorry, yeah, I will finish it from here, right? I will finish it from here. Actually, I'm going to finish it. I'm not going to complete it today, but I will finish within like 5 minutes, right? Uh, okay, so yeah, so I'm going to now take this x and y, and I'm going to create like get like, let's say, okay, you are going to press something here in this point, let's say x and y, x and y. So what I'm trying to do here is simply define x2, x1, y1 and y2 like this, right? Right. Understood. So then what I'm going to do, so the offset is 30, you can see offset is 30. So then what I'm going to do, I'm going to quickly create a oval. Create a oval. So in order to create the oval, what we are going to provide is x1, y1, x2, and y2, and it is filled with black, right? So what happens? Once you press something inside the canvas, it will create the oval like this. So those are the x1, y1, y2 parameters should be given in order to create the oval. Right? For example, oval like this. Right? So now what happens then? If you run this again, now the drawing is done, right? Now the drawing is done. Okay, so I will stop it from here. Why x minus 30? Now you can see uh, these values can be changed, not 10. I mean, you can use it like 10 also, not always 30. It is a parameter with the thickness of the line. See the thickness, right? Yeah, x is the center. X is the center, right? And it creates a oval bounding x1, x2, y1, and y2, right? So it simply like create oval. What this simply does is it creates a oval bounding x1, x2, y1, and y2. X and y is the center. Yeah. So it gives like no, the radius of the this oval will be 30. The diameter of this will be 60, right? 60. Right. So I'll stop from here. Now you can go up to now. Now I will finalize the GUI tomorrow, and also the model integration and prediction will be done tomorrow. Like we will take like half an hour tomorrow, and we will go to the next project tomorrow, the face recognition using support vector machine. Okay. So before winding up, any issues you may have quickly? Yeah, I will. Yeah, I will upload it today, right? And you will get. So did you got the? Did you get the yesterday video? Did you get the yesterday video? Okay, when? When did you? Ah, you got it today. Yeah, the code is also already there, right? The code is already there in the day one and day two materials, the code is there. Yeah, okay. I will, yeah, actually I upload the video yesterday as well, but yeah, sorry about this. Now I will try to minimize these kind of issues from today onwards, right? So I will try to send it to you today itself, right? And the Python tutorials, everything. Not the complete code. I think the code is there, not? Yeah, the others can leave. Those have errors, those have issues can wait. You didn't got. Can you send your email quickly for me? I will check about. I will ask him to check. Shital, now can you send me your email? I will check about that. Those who don't have any kind of issues, they can. Yeah, it's here. This one. This not contains the whole code. I think this is there, right? In the day two. You didn't got this the all the materials. You didn't get the all the materials like day 5, day 6, all the day 6 materials. You got only the day 1. You have, right? Yes, you have all the materials with you, right? Yeah, yeah. So the day 2 materials, you can check the day 2 materials. This code is there. You can check it. Okay. Yeah. So Vinny, can you send me your correct email? So I will pass it to the. Yeah. Okay. Yeah. Tomorrow we will do the full implementation, but the already implemented code is there, right? So I think I missed something. Can you explain how to install modules in Anaconda? Yes. What you can do is simply go to the uh, go to the yeah. So you have to go to the Anaconda prompt, right? Sorry, you have to go to the Anaconda prompt and just pip install whatever the module you want. If you want to install OpenCV, it's like this OpenCV Python. If you want to install the pillow library, it's like this. Whatever the library name you have to provide, so it will install it for you. Yes. The today lecture you will get it today itself, Ragi, right? Tomorrow will be the doubt. Yes. Yeah. What's your message? What's your doubt? I don't have. Yeah. Dot say, as I mentioned, dot sav is the extension, the standard extension provided by the scikit-learn to save their models, right? SAV is the scikit-learn model. I mean, that's the extension used by the scikit-learn. to save their models. Yeah, what's your doubt? I can't exactly. Uh, I don't. I don't see your name. 180 BD 1A05. You have a doubt, right? What is the doubt? Yeah, you can. H5 extension is used. Yeah, H5 extension also can be used. I'm not sure, but that can be used for neural network models. I'm not sure whether that can be used for machine learning models as well, but for neural network models, you can use H5 model, H5 extension. It's kind of encoded now. We have which type file is KNN SAV. Now, it's a kind of encoded version and it can be only opened with scikit-learn. It can be only opened with scikit-learn in Python. So if you are developing a Python backend, you can use that there. Okay. Okay, what about the parameter inside the event function? What the event here? Event function, yes. So what this event actually are? So this event is actually contains the information about the event occurred, right? Now I told you this event function will be called when this event is occurred. So this B1 motion occurs, right? So when the B1 motion occurs, this event function actually the event parameter contains all the information about that event occurred. For example, now we are in the B1 motion, so this actually has the x coordinate and the y coordinate of where the mouse is, right? Okay. I think okay, you are confused about the where the SAV file saves, right? Okay. So now I think is this my So this is my code, right? So where my code is, this file will be saved in where your code is located, right? So if you want to save it somewhere else, let's say okay, you want to save it here. I mean here, let's say, if you want some random location, right? So what we have then provide here, put a R, and then you have to provide the location, right? So if you write it like this, now it will save this file. Sorry. Right. Sorry. The algorithm is already given. Right, sorry. Right. So now what happens? Now I can save it here, right? So this location. See? Now it's saved here, right? Okay, so another question, what this one? This one, the Ravi Kumar, I will explain it tomorrow. That's something to do with the machine learning prediction thing. I will explain that tomorrow, right? So up to now, this is what it does. Right. So any other questions you may have quickly, if there is anything? Okay, great. So again, I'm sorry about the issue that you are going to you have faced with this module and the Python basic, right? You will definitely get it today itself, right? So Kumar, now you are getting an error, right? So I think probably the error is due to this one. Let me check quickly. Uh, you have to install these library below OpenCV, right? So how we are going to install them? That's why you are getting errors. So install this using pip install below and pip install OpenCV Python. So that will solve it using the sorry, the OpenCV is simple OpenCV Python. Right. Right. Okay. Okay. So any other issues you may have? Okay, then. So I will finish it from here. So thank you very much, and we will meet with the remaining part of this and the face recognition algorithm implementation tomorrow. Right. So thank you very much, and we will meet tomorrow. Okay. Right. I will send it.